Hello, everyone, and welcome back to yet another episode. We've got Fiodar with us today. Hi, Fiodar.
Hi.
Fiodar, just before we start, I think it would be good to check if we are the only ones here or there are people who've joined. So if you can hear us, uh, please add in a comment saying hi and where you're joining us from. That would be helpful for us to know that we are not alone in here. Let's just give them a minute. And
Yep.
yeah, if we don't hear from anyone, that's completely fine. We'll start after a minute. I can see quite a few people are joining in. The numbers are going up. But yeah, if you can hear us, please comment and say where you're joining us from. Well, yeah, that made sense. Okay. At least there's one comment. Like I can see
Yes.
Muthu Kamalan from YouTube says, Hi, I'm Muthu from India. Thanks for confirming, Muthu. Then we've got Amir Sajad. Hi there, I'm joining from Pakistan. Welcome, Amir. Then there's another one. Hi there, Puerto Rico. Sequel Dev DBA. Thanks everyone for confirming. So, uh, just a reminder there's a ticker going on at the bottom, and the ticker basically says that there are two giveaways to win a chance to win a free MEEP of Yodar's latest book. Uh, if you want to win, just comment hashtag AI. Sorry, hashtag ship for this one. Just comment hashtag ship, and we'll do a raffle somewhere in the middle of the session and one towards the end. And yeah, all the best. A lot of people are joining in. Thank you for commenting. Jonathan, hello from Peru. Hi, Jonathan. Hello from Brazil. Alexandre. And someone from LinkedIn, hello from France. Welcome, welcome.
Mhm.
Thanks, everyone. So, Fiodar, while we are waiting for others to ask their queries, if you have any of your queries, please feel free to pop in on the chat and I'll get Fiodar to answer them for you. And while we are waiting for others, I think I'll start asking my queries. So, Fiodar, the first question for you: why do distributed systems feel so hard to ship with confidence?
So traditionally, if you wanted to ship distributed system,
Hmm.
you had to launch things as individual services because essentially what distributed systems are a collection of individual services that act as a single system.
Right.
Uh, they have to be orchestrated. So, for example, you cannot start API service until database is available. You have to have some kind of a database. You have to have
Hmm.
all these infrastructure components in place. I'll give you an example. I used to work for Microsoft when Aspire was becoming a thing. And when we weren't using Aspire,
Hmm.
we could only run a subset of services at a time. And in that particular instance, occasionally it would lead to some integration problems when
Yeah.
one team would work with one bunch of services, another team would work with another bunch of services. They could only run a subset of those services locally. And when the complete application gets deployed, those two sets of services just don't work with each other.
Yeah.
Integration defects. That's one of the examples, but there are many other things like that as well. Just because of the sheer structure of the distributed system, it's difficult to ship.
Perfect. So I can see a lot of people have started commenting. Hashtag ship. There's
Yeah.
Viz on X. There's Amir on YouTube. Raghav on X. Thanks. And yeah, others, if you haven't commented, I can see a lot of people have joined in. So please comment hashtag ship. They're doing this because there are a couple of giveaways as the ticker is on the bottom. And if you have any questions for Fyodor, please add them to the chat. And yeah, until then, I'll keep asking my questions happily. Uh, so, Fyodor, as we were talking, here's my next question to follow up with that. What breaks when teams move from one app to many services?
Many things, to be honest.
Mhm.
So usually, according to the best practices, the way applications are developed is you start with a monolith first. So
Right.
your first version of the application is monolithic. All the services are going to be inside of it.
Hmm.
As your application scales, so for many businesses, maybe for majority of them, for majority of teams, you will never even have a need to go beyond monolith. But
Hmm.
if you are building a real enterprise application that serves many users, you will eventually have to start splitting it up and making it distributed, or maybe adding network components. And because there are so many different moving parts involved, things start breaking. So, for example, when your original tests covered a single application, now you have to rewrite your original tests to cover all the network connections, additional infrastructure, those
Mm-hmm.
kind of things. So because you are rewriting tests now, you no longer can use those as guards against regression defects,
Mm-hmm.
um, because your tests are brand new essentially. Uh, then yeah, or those things that I described before, when integration defects occur, because new moving parts get created.
Right.
Some things just to kind of drift away from each other. So while things were inside of the same application, they were tightly coupled, well, reasonably tightly coupled.
Mm.
When you split it up, you introduce different dependencies, you introduce additional network. API may potentially change, some business logic inside those services change, and they may even become incompatible.
Mm-hmm. Nice. Thanks for that. I can see we've got a few questions in. So on YouTube, Muthu inquires that mental model for stateful set is always hard for me. How to break down and digest.
Stateful, like by default, you should apply stateless first mindset.
Mm-hmm.
The only thing that should be stateful, or this question specifically about stateful set.
Mm-hmm.
Uh, yeah, I probably won't be able to answer that much because I haven't been using stateful set.
Okay, that's fine. We've got other questions as well. So we've got someone on YouTube inquiring how does implementing distributed systems affect high availability and load balancing? More setup and maintenance or less?
So distributed systems are primarily built for high availability. Load balancing is essentially just the algorithm that allows you to run multiple instances of a service.
Mm. Yeah.
It doesn't really kind of have any relationship to whether it's a distributed or monolithic application. What load balancing is that you're running multiple instances of something, usually stateless application, and you have some kind of a load balancer in front of them, and that load balancer sends requests to specific instances, so no individual instance gets overloaded. So, for example, if the full capacity of your instance is to receive, let's say, 1,000 requests, then you have three instances, and now you have 3,000 users. And the job of load balancer is to distribute those 3,000 requests across those three instances evenly. So not a single one of them gets overloaded, and every one of them stays within the capacity. In terms of distributed systems, if you split it up into individual services, then load balancers get applied to individual services and not the whole application. In this example, you may have three separate instances of application front-end service, but it might be different for API. The API service for the backend might be behind a separate load balancer for that. It might be behind its own API management or that kind of thing. So load balancing is definitely part of distributed systems. And high availability, yes, basically high availability is one of the main reasons why you want to split your monolithic application into distributed systems, or even go as far as splitting it up into microservices, which are kind of getting out of fashion these days.
Mm. True. Okay. Thanks for that. And I'll ask my next question. So, how does Aspire make cloud native .NET development less overwhelming?
So Aspire, which is not as popular as it should be, is a tech stack that was developed by Microsoft back in 2024. And when I was working at Microsoft, we weren't using Aspire in our project to begin with. It was the project was about building a large-scale application that transfers weather and climate data from supercomputers via the cloud to end user. It was one of those scientific government organizations that was the client for that. And when we introduced Aspire, we never had to again run individual subsets of services of that application. We could just launch the entire application because Aspire has orchestration as the code concept. It comes with this special type of .NET project known as Aspire Host. Aspire Host links all the projects together. So locally, if you want to launch your entire distributed system, all you have to do is just launch that one project, and it launches the entire system for you locally. All the applications, all the services, all the infrastructure, Aspire has many different libraries for you to emulate different infrastructure components,
Mm.
emulate or outright run them, like some Azure components or traditional databases, message brokers, those kind of things. And all of this setup, the applications that you have, front end, back end, all these additional workers, all these infrastructure components get launched together just by launching that one app host project. And the best thing about it is that it all gets attached to the same debugger instance. So you will be able to trace your each individual request end to end throughout the entire ecosystem. So as it goes from front end to back end to some worker service to something else, you will be able to trace it all locally.
Sounds quite seamless, to be fair.
Yeah.
Uh, so, yeah, SQL Dev DBA is
Mhm.
thanking you for the response that you gave earlier. There's another question in from Raghavan on X. Raghavan inquires that there are a lot of changes, paradigm shift after microservices in the distributed computing. Could it be any better or simpler?
Um, I would say this simpler the simplest setup you can go with. You will still have separate services, but those won't be microservices. I've seen this setup quite successfully implemented in the companies that I consulted for or worked for, where you still have the domain application. So, like for example, your backend API application is still a single application. Front-end application is usually separate, so you already have two separate services, kind of. But you're not going to be splitting the entire backend application into further services. What you will have instead is various stateless components. So, for example, this particular event listener can be just a stateless application. You only ever need to invoke it when you actually need it, like maybe once a day. In which case, making it as a stateless function in Azure or AWS probably makes more sense than having it as a permanently running service inside of your main application.
Mm.
You will also be using less CPU. For those who are not very familiar with serverless, it's basically when your application brings up is launched only when it's needed. It's kind of dormant, so it's not using resources, or it's using a minimal amount of compute resources while it's waiting. And then it just creates an instance when it's actually needed. And if it needs to deal with a lot of load, it scales itself out. It creates many instances of itself, and then it scales it back down. So
Mm.
you don't have to manage it manually. And obviously, the other infrastructure components, you will still need some kind of a message broker. You will still need some kind of asynchronous components. So those will still be separate services, but they're not necessarily going to be your own code.
Thanks a lot for that, Fiodar. So my next question is, how can developers manage databases, caches, queues, and containers without drowning in the setup?
That's a very good question. So how to answer that? Because this question is very loaded. It has different things that are not necessarily related to each other.
Okay.
So what I would always say is start with monolith first approach. Anything that needs to be asynchronous, start with just simple kind of asynchronous code first
Mm.
before you do anything else. What do I mean by that? Just use async await kind of task-based things. Then when there's a genuine need to make something genuinely asynchronous. So, for example, you are building an actual payment portal. A customer orders something. They cannot wait until your order is fully processed. They will just need to see the confirmation that the order has been placed. But
Yeah.
the order processing may take a very long time. So in that situation, you need some kind of a queue. In that situation, start with the simplest, most queue implementation possible, I would say. You can start with RabbitMQ right away. Like RabbitMQ is, for example, industry standard as a message broker. But don't do anything too complicated with that. My personal preference, I usually start with the Azure storage account. Most of the work that I do is in Azure. Because like storage queues are the simplest kind of queue implementation you can ever get. Then caches. Caches are not needed until later. So first thing that I would do with caches is just add inbuilt caching mechanisms, like output caching that comes with ASP.NET Core, for example, if you are a .NET developer, or any other similar kind of mechanism. Because I think any web application development platform comes with some kind of output caching mechanism. Use that. If there is any other library that caches things in memory, use that because it will have a very simple interface. Only after there's a genuine need for scaling cache and making the cache shared, start adding something like Redis, distributed caching, distributed locking, those kind of things.
Mm.
So yeah, to make sure that you are not overwhelmed by this, start simple. Only add features as you need it. Remember, you ain't gonna need it principle, which is like age-old principle of software engineering. Don't do anything that you might need in the future. Only do the things that you actually need now.
Perfect. Ragwan from X is thanking you for the response earlier. And we've got a couple of more questions from people who've joined in. On YouTube, Concepts in Tamil inquires, do you consider agentic applications are just distributed systems with LLM API wrapped into it? Or does it add any new problem statement for being agentic?
It has many new different problems, but at the end of the day, agentic systems are, I wouldn't necessarily say distributed systems. They are more like distributed orchestrated workflows.
Hmm.
Yeah, it's kind of distributed because what agent is at the end of the day is just some kind of a code that interacts with LLM. It has system prompts, which are things that it runs via LLM internally, and it has some kind of inputs coming in as other agents or humans, just sending chat messages to it. So yeah, code-wise, it's just a distributed workflow with LLMs connected to it. What problems and challenges it introduces? Oh, there are so many different ones. One of the things is evaluating, because LLMs are not, well, I don't know if I should use the word non-deterministic, because, like, strictly speaking, they kind of are, because, if you receive exactly that response on exactly the same machine setup, it's kind of deterministic, because nothing is truly non-deterministic in computers. But at the same time, they are practically non-deterministic, because if you send the same request to the same LLM several times, it will be a different response coming back. And because of that, for example, you still need to test them somehow. You still cannot just test them manually.
Hmm.
But because they are non-deterministic, you cannot use traditional unit tests, integration tests. You have to use agentic evaluations. For that kind of thing, you have to create large data sets of different questions. You have to cover every single scenario from different angles. You cannot just have one test per scenario. You have to have multiple different either user questions or some kind of event-driven signals, because agentic systems can be either user-driven or event-driven. Yeah, and there are other things as well, like guardrails, making sure that your secrets are not touching the same part of code that LLMs are touching. That's a very important one. Many companies got burned by that when agents were just sharing private user information with each other.
Perfect. Thanks a lot for that. There's another question on YouTube by Muthu who inquires that what is the knee point where we move to monolith to monorepo and microservice? What is your rule of thumb?
What is knee point exactly? What is that? Yeah, I'm not familiar with the terminology.
Yeah, even I've never heard the terminology knee point, but I think what is your rule of thumb? Let's consider that as a question that where you
So
turning
my
point, knee point
preference,
will be.
right? So I worked with different setups. Some of them used the mono repos, some used separate repos for separate services. Based on what I've seen in the field, I used to hate mono repos because they were just too complicated. But based on what I've seen in the field, I actually prefer mono repos now. For example, that application that I described, that I was helping to develop at Microsoft, that was a huge monorepo, very large. It took a couple of minutes to start up, even with Aspire, but it kind of yeah, it made sense because it was a large application. What I tend to do is just start simple, keep the application in the same repo, just keep adding bits to that repo, other services, those kind of things. Monorepos might be uh, monorepos used to be problems in the past because IDEs were not as good as they are today.
Hmm.
And now IDEs are more efficient. So, like for example, it used to take quite a bit of time to just open monorepo before, if it's large. These days, even with large monorepos, I'm not seeing this problem anymore. But everything is in the same place. Everything is searchable. You can trace everything, how different services interact with each other, because everything is in the same repo.
Perfect. There's a praise coming up for you, so brace for a moment. David on LinkedIn says that Fyodar's explanation of testing non-deterministic models has influenced how I do it. Can
I'm
you
glad to
briefly
hear that.
explain? Yeah, can you briefly explain what does that mean?
So me and David know each other, and we chatted about it. I wrote an article, shared an article with David. So basically, I shared an article where I provided quite a long explanation of different uh, important points of doing AI evaluations.
Hmm.
And yes, but basically the key points are that you have to have quite a large data set. There's a difference between deterministic and non-deterministic metrics. So, for example, deterministic metrics are things like how long does it take to execute your agents, those kind of things. What kind of tools are being called? Because agents might have different tools or agent calls, skill calls, those kind of things. Your evaluation report should probably have all of those. So it's not just pass and fail. Yeah, the most important thing in agentic evaluation that it cannot just be binary pass or fail. It has to be scored. There has to
Okay.
be some kind of a rubric, some kind of a set of rules that your agents are scored against. And you still can have a kind of some kind of pass or fail threshold. Maybe like if the score is 80%, then it's pass. If it's below that, then it's fail. The reason why it should be scored rather than be just pass or fail is because because it's not deterministic. How do you test outputs? How do you actually define criteria for testing output when the output is not non-deterministic? You would typically use something that is called LM as a judge, so a separate agent that tests the output of your agentic system. And for each scenario that you have in your evaluation data set, you would test something in a context unaware way. Like, so, for example, your LLM is testing whether the answer provided is relevant to the question that has been asked. But you also can have or should have context-aware evaluations where some judge criteria, a system prompt, short system prompt, describes that for this specific question, this is what you should expect to see in the answer. So, for example, if the question is about a particular device, you should see this device serial number there. Or if your database contains 3 items of a particular kind, you should see 3 results, that kind of thing. So it's not excessively detailed, but it provides some context of what should be expected to be seen in the output. And I guess it's some of this that influenced how David tests his application.
Perfect. Thanks a lot. So I'll ask one more question, but before that, I would like to remind people that we are going to do our first raffle after this question. So if you want to enter the raffle and win a free MEEP of Fyodar's latest book, How to Ship Distributed Systems, have a look at the ticker. Comment hashtag ship. A lot of people have done that. I can see, there are over 60 people who joined us live and only 9 people have commented. So yeah, comment hashtag ship. I'll ask my next question, Fyodar, and then we'll go and do the first raffle. So here's my next question. So why is local orchestration such a big pain point for distributed apps?
Right, because if you don't have any specialist tech stack like Aspire, you're going to be having a problem running your entire distributed system locally. Uh,
Mhm.
so for orchestration, what orchestration does in a distributed system, it makes sure that services that depend on each other are started in a specific order that makes sense. So, for example, you shouldn't be able to start API service if database that it relies on is not available. It doesn't really make sense to start web front end unless the API that it will be talking to is available. And it's basically this dependency chain. That's one of the pain points. Every one of these components, the infrastructure components and the services, has its own address as well. You have to know its IP address. You may have some kind of configuration file locally, but you will have to maintain it. You will have to make sure it's up to date. You will have to. If you are unable to use the full-on orchestrator, so for example, you probably won't be able to run a proper Kubernetes system locally on your machine. If you don't have that, you have to do all these things manually, like service discovery. Service discovery is basically figuring out the IP address of the service that the other service that you're launching is meant to connect to.
Perfect. So, as promised, we are almost at the halfway mark. So, let's do our first raffle. I'll share my screen, Fyodor. If you can see it, let me know. Has it popped up?
I can see it.
Okay, so as I can see that 9 people have commented hashtag ship. So let's do our first raffle. Let's see who is the first winner. So they just asked a question. So Concepts in Tamil on YouTube is the first winner. Please get in touch with me. Or if you know Fyodar, get in touch with Fyodar. For anyone else, do not be disheartened. We are going to do another raffle. Uh, yeah. Yeah. I'll ask my question. I'll continue doing that. Keep commenting hashtag ship as the ticker says at the bottom, and we'll do another raffle towards the end. So, Fyodar, how does Aspire help teams see how all their services fit together?
So Aspire was specifically designed for that. So Aspire comes with its own dashboard. I briefly covered previously that Aspire comes with app host project that links all the services together, acts as orchestrator and the glue for them. One thing before I go to this specific question, to continue from the previous question, is that
Yeah.
Aspire does all the service discovery for you. You don't have to know any specific addresses, ports of any services. You just label them, and Aspire does everything for you, all the connections, service discovery. But on top of that, how does it help you to see all the services together? When you launch your Aspire application, you will see the dashboard. Shall I share my screen, maybe,
Yeah.
and
Yeah.
actually demonstrate it?
Yeah. Go for it.
Right. Okay. Just give me a second. Share. Let me know if you are seeing my screen.
Just a sec. So while I pop that up, I can see Concepts in Tamil has registered that they won. Please get in touch with me. And here's Fyodar's screen coming up here. Go for it, Fyodar.
Okay. So what I have in front of me is, I'll probably zoom in a little bit to make it more visible, is one of those app host projects. So as you can see here, just the ordinary C# code, but it has reference to various services. It has references to, first of all, Docker containers, because it uses Docker, but it also has services running inside of this solution. I have API service, I have web front-end service, I have various infrastructure components. If I then launch it, here's what's going to happen. So I just need to wait for this to start. It will essentially start all the services together. Here we go. It's starting it now. And it displays this dashboard.
Nice.
So all of the services and all of the infrastructure components are displayed on the dashboard. You can see all the statuses, whether they are running, whether they're still starting. Like, for example, API service is still unhealthy at the moment. You can see what the services are. You can emulate many different things. But on top of that, what you can also see, so if I'll go into, both of them are started now. I can click console logs. I can monitor console in each service in real time. I can view structured log. I can search for things. So structured logs has a severity level, like information, warning, errors. I can see traces So if request happens, I can see which services were contacted. So for example, in here, this API service goes to cache, then goes to storage, which I think in this case is Azure storage account. There are metrics as well, which are basically simple values of like counters, durations, those kind of things. So yeah, all of this is inbuilt in Aspire Stack. Even when you launch it to Azure or AWS, you'll still see this dashboard. So yeah,
Perfect. Thanks a lot for that. Yeah, I just shared the entire screen so that we are not visible, but the screen is clearly visible.
right.
I
Awesome.
hope everyone found that valuable. And moving on to the next question. So, how can developers test distributed systems before production exposes the problems?
The biggest kind of category of defects that I've seen traditionally in distributed systems, integration defects. So as I described previously, one team works on subset of services here, another team
Mhm.
works on another subset of services. They're supposed to be talking to each other, but they are not while they're being developed. Like this team mocks this subset of services, this team mocks this subset of services. They write tests, that a kind of integration test that they test the entire subset of services with network connections, but this boundary is mocked still. And this does not prevent you, this does not protect you from integration defects. How it can be done with Aspire? Aspire has its own integration testing framework that allows you to test the entire thing end to end. So yeah, because your tests cover essentially all the way the request travels from API to backend services to other components of the app. Those tests become meaningful. They test the actual behavior. They implicitly test all the APIs and interactions in the infrastructure that happen in between. And that's the only way to be confident, because if you are just doing component testing in distributed system, you can be sure that your component is doing what you think it should be doing. Not that it works, but it's doing what you think it should be doing, which is a very important distinction. But yeah, component testing on its own will never prevent integration defects.
Thanks for that, Fiodar. Yeah, so one second, I'll just clarify this quickly. Concepts Tamil is inquiring how to get in touch with me. Please share my contact. Uh, well, you can type in my full name, Tushar Gupta plus Manning Publications on LinkedIn. Add me up. Easiest way to get in touch with me. I'm forever on LinkedIn. So yeah. I'll follow up with my next question. Wait, have I got this answered? No. Yeah, there you go. Why is observability essential for debugging cloud native applications?
Observability is essential for debugging any kind of application, not just cloud native, because observability is showing what's going on in the application. And there are three main types of observability that you need to be involved in. There are detailed logs. So essentially, when something happens, something is written in the log. Uh, Logs have different severity. So, for example, if it's just a normal operation, normal event that happens in application, that's information severity. If something is extraordinary, but it's not a big problem anymore, but something that you might want to be aware of, it's a warning. If it's some exception being thrown or some payment gateway failed, that kind of thing, it's failure. And that is also critical when some important part of application is broken and it just cannot fulfill its role at all. Something is critically broken. Um, you can't rely on logs on their own, because they're just going to be too much. You cannot just, because applications, especially cloud native ones, they generate logs all the time. That there are so many of them. They get archived all the time. So you have to have another thing called metrics. Metrics are just simple values like counters. Like, so for example, error occurred +1, another error +1, and you basically just see graphs with spikes. Then there are durations. So for example, uh, uh, all kind of durations of requests are measured over time, how long it takes from request to send a response back. And then they plot it on the graph as average duration, so that there might be like a spike here, that kind of thing. If you look at metric graph, you can see those spikes, and it helps you to narrow down where in the logs you should be looking for the things. So it basically helps you, because it's time series data, it helps you to narrow down to a particular point in time that you have to be checking the logs. And there's also traces. And traces is essentially those things that link different log entries together via some kind of shared identifier like correlation ID or process ID. And this allows you to not just follow the log entries as individual log entries, but to follow all log entries that are involved in particular flow. So, for example, it's a single request or single database transaction. Traces allow you to see what happens throughout your entire system in all the services that are involved in this particular flow of a request. And
Mm,
yeah, and on top of that, you have to configure some kind of alerting rules because you can't just sit there and monitor all these things yourself. And alerting rules will allow you to be notified if something goes wrong, if, for example, errors reach particular threshold, if some critical errors occur, you will receive PagerDuty or Slack message or something instantly.
perfect. Just to clarify for concepts in Tamil, I found your YouTube channel, and fortunately, your YouTube channel has your email address in the About section. I'll email you post a session with the discount code to claim the book for free. Congrats once again. There is a question on LinkedIn. So Jonathan inquires if you're familiar with Dapper.net. Do you have an opinion on using Dapper.net together with Aspire?
Um, so what we did at Microsoft, when I joined, we used Dapper.net specifically. We replaced that whole thing with Aspire. So Dapper.net does not is not like a full equivalent of Aspire because Dapper is both orchestration and workflow framework. What we did in that particular instance is that we replaced the orchestration part of Dapper with Aspire, and we replaced the workflow part of Dapper with durable Azure functions, which were running inside of Aspire.
Nice.
It's a lot more difficult to manage. So, for example, yeah, Dapper is a good framework. Don't get me wrong; it's been there for quite a while. But for example, onboarding of new team members used to be quite long because there were so many different things that you had to set up manually in Dapper to run it locally. With Aspire, you just literally check out the repo and you run it. That's it. Because
Amazing.
everything like addresses, although you don't have to manually configure it locally because Aspire will already pre-configure it for you and use service discovery.
Right. So I'll pop up my next question. So we've been talking a lot about the book and all the things that it does and about the technology as well. So how does the book help developers move from it runs locally to its production ready?
By book, we're specifically referring to Ship Distributed Systems with
Yes. Yes.
Confidence, which
Yes.
is it's basically a book about building cloud-native applications by using Aspire, and it takes you from the journey of just building a simple application, adding various infrastructure components to it, and towards the end, it shows you how to actually deploy it in production. So Aspire integrates with a tool. In Azure, it's called ADZ. I can't remember what it stands for. Like A stands for Azure, but essentially, it's a tool that converts this glue code, this Aspire app host code, into deployable software as a service, infrastructure as code templates. By default, if you don't install any other libraries or nothing like that, by default, it deploys the application that you built by using C# into Azure Container App, but it also has within its ecosystems many libraries that, for example, integrate with Kubernetes or allow you to deploy it to AWS. All of these are official; they are officially endorsed by Aspire. So it can be in exactly the same way as it can be converted into Azure-specific uh, uh, infrastructure as code templates. In exactly the same way, it can be automatically made into the equivalent thing for other platforms as well. And it also has various scripts that allow you to automatically convert your application into CI/CD pipeline script. So you will have a release pipeline pre-configured for you. You don't have to set it up manually. You might still have to come back to it and tweak some things manually, but the core of it all the main steps like tests, build, deploy, provision the infrastructure, they will be part of your first pass CI/CD pipeline template.
Thank you. So, what should teams know before deploying Aspire apps to Azure Container Apps or Kubernetes?
They should be familiar with either Azure Container Apps or Kubernetes. That's the main prerequisite. But other than that, they need to know a couple of command line commands to do it. It's fairly simple with Aspire to do it because that tool that I mentioned, ADZ, that's for Azure Container App, but the Kubernetes equivalent is also fairly simple to use.
All right, that was pretty straightforward. So let's take the next question up.
One thing that I would add to that is that
Yes.
if you want to make updates to your application, keep your app host as a source of truth because the infrastructure as code scripts generated by those commands will still read your app host and they will get regenerated. So if you've been modifying them directly, you will lose all the changes.
Thank you. So the next question is, how can messaging and caching improve reliability in distributed systems?
So messaging is not there exactly for reliability. They are there to distribute asynchronous workload. So an example of that is I keep quoting payment portal because it's the most obvious example. User orders something. That order might then get passed to some workflow that might take quite a while to run. So it might be like adjusting stock, notifying some external system, notifying the system of the delivery warehouse, assigning the driver, that kind of thing. It might be a long-running workflow. What you don't want to do as a customer is stay on that page while this whole thing is happening. It might take an hour. I don't know. What you need to do is receive a message that your order has been placed. So messaging in this context fits where you make that payment request. A message gets created with the details of that particular order. It gets sent to some external system. The main application sends response to the customer that order has been placed. So in that context, the role of the message is to outsource it to some system that processes your order asynchronously. And this is what messages are for in general. Caching is basically in-memory storage, whether it's typically in memory, but it's designed for fast data retrieval. So your data is stored in a database on a disk normally. The disk is slower than memory. And also you might have many different requests to the same database coming from many different users, which will slow it down even further. So for data that rarely changes, so for example, product description. Product description is probably not going to change until there's a new version of that product released. Even then, the old version will probably still have same description. So for that kind of thing, data might be cached. When it's cached, it does not get retrieved from the database again for every single request, for every single user. It gets retrieved from the cache, from the memory. Retrieval from the memory is quicker, and also there are different types of cache. Some of these types of cache are local to the user, so it might be in-browser cache, or it might be like semi-local, so it's not necessarily user's browser or user's device, but it can be some part of application that is associated with the user, some kind of cache entry with a unique user's identifier. So yeah, basically caching cuts that additional round trip to database, so data gets retrieved faster.
Thanks. And what security issues appear once an app becomes distributed?
You have to pass your authentication details throughout different services. So, for example, if you're not allowed to go to a particular page unless you're logged in or logged in and have a particular role, if that page uses some kind of a backend API, then those API endpoints need the same level of protection, exactly the same. So you have to have a mechanism in place where something that you can use as your credential confirmation, like access token, something like that, can be passed throughout these services. In this particular example, even though it's simple, it's not necessarily like full-on distributed example, but it's still simple and common example. User logs in. The identity provider system that allowed the user to log in sends access token as the confirmation that user is logged in, authorized. It's got signature in it, cryptographic signature. It's got roles that user has been granted. Then that token needs to also be passed to the request that goes to the API to make sure that API itself cannot be accessed by anonymous or unauthorized users.
Amazing.
So more things to secure, more moving parts that you have to worry about. That's the main challenge.
Thank you. So, how can teams bring legacy .NET apps into modern Aspire-based architecture?
With the latest version of Aspire, well, not necessarily the latest, they have introduced it. Well, kind of the latest because the current version is considered evergreen, Aspire 13. There is a Aspirify command. I think it's
Mm.
Aspirify, but basically there's a dedicated tool that gets installed together with your .NET workload on your machine. That will just allow you to basically, if your .NET app is stored in a solution, you run that command in that solution. The command creates a app host project for you and basically enrolls those projects in app host automatically.
Thank you. So,
So it used to be manual
uh,
process, and now it's a just a single command line command. And you can do it via IDE by right clicking and selecting as well. It's equivalent of that.
so if anyone wants to add any questions for Fyodor, please add them in comments. I've got my last two questions left and a raffle to go. But yeah, if you want any questions answered by Fyodor directly, feel free to add them in the comments. We'll take them up. So while we're waiting for them, I think I'll add my question that I had. So, what are the most common mistakes teams make with service to service communication?
Not technical. I think I mentioned the mistake a couple of times during this call already, but it's not necessarily a technical mistake. It's more to do with different teams working on different services that
Right.
are designed to communicate with each other, and they end up building something that isn't fully compatible.
Mhm.
It's more to do with the way of working rather than a design mistake. Um, Another thing I would mention is probably because services need some kind of APIs to communicate with each other. So
Mhm.
client service, the service that sends the request, needs to know the shape of the API of the server service. Those APIs will inevitably evolve over time. So quite a big mistake that I saw quite a few times is that not having versioning strategy in place. So what happens is that there's some new feature, some new API endpoint has been added, or some old endpoint has been modified because people realize that actually it would be more optimal if it's structured this way and not that way. Nobody told the team that was building the client service, and now here's where integration defect happens. When you are working on different services, you have to have some kind of versioning strategy in place, which again with Aspire is not as relevant because your entire thing is uh, kind of one monorepo. So it's much easier to just maintain the most up to date contracts between client and the server, even without version strategy in place.
Right. Thanks. So in simple words, it would be just like a Google Doc, like everyone can see what the editor been making and what's going on.
No, version strategy is not Google Doc. It's
Yeah. Just
for APIs, for example. API
yeah.
document is going to be live document that,
Yes.
like Swagger, for example, Open
Yeah.
API. You
Yeah.
launch application and you can see live what endpoints the
Right.
application has. API versioning is like, for example, having like v2 slash something, So
Mm-hmm.
this is version one, this is version two of your API endpoints. And when you want to make any changes, you don't make changes in the current version. You just publish new version of
Mm-hmm.
the API, that kind of thing. You still need API documentation. I definitely wouldn't have Google Doc as API document. I would just have live documentation as
Yeah.
API documentation. Like a lot of people on this call would be familiar with Swagger.
Yeah, yeah,
Swagger basically generates API definition from the
mm,
actual live code.
yeah,
All you have to do as a developer is annotate those API endpoints with human readable context so
yeah.
they can actually understand what those API endpoints do.
Yeah, it was a silly question about just trying to simplify, oversimplify things about how
Yeah.
people parallelly work together. But yeah,
Yeah.
you beautifully answered that, and yeah, thanks for that. So, I've got my final query to pop up. While I'm going to pop that up and read that out, just a reminder for people, we've got a final giveaway left, which is after this question. There's a ticker going on at the bottom. Comment hashtag ship, as the ticker says, and you could stand a chance to win a free meep of the latest book that Fyodor has written. So here's my final question for you, Fyodor. Who is this book for? And what will they be able to ship after reading it?
Because book focuses on .NET examples in particular, it's primarily for people who already know .NET, but it does not assume that you know anything at all about cloud application development.
Right.
So anything about distributed systems, cloud applications, nothing like that, because it basically will teach you all these concepts. And it also quite a good fit for people who know those concepts, who have been working with .NET, who have been building cloud applications, but haven't necessarily tried Aspire yet.
So can they learn the examples in .NET and apply it in different languages if
It
needed?
can be, yes. Aspire, I think, is available in JavaScript and Python as well, if I'm not
Yeah.
mistaken. I don't know if it's available in other languages. Might be Go. I think there was a discussion about it, but I haven't really used it in other languages. Yeah, so some of this can definitely be applicable to other languages. Plus, with LLMs, it's quite easy to translate code samples into different languages if you are, for example, a Python developer. Most of the things that Microsoft does these days are not just .NET centric anymore.
Mhm.
They usually build them for .NET, Python, and JavaScript by default.
Mm.
Like for example, the Microsoft Agent framework, framework for orchestrating AI agents. It's available in .NET. It's also available in Python, and the same applies to Aspire as well.
Mm.
This is why they don't call it .NET Aspire anymore, because the first
Yeah.
version used to be called .NET Aspire. They
Yeah.
call it just Aspire because it's not .NET only, not the .NET exclusive tech stack anymore.
Amazing. It's good to know that it's agnostic and all the concepts that are learned
Yeah.
in the book are not limited just to .NET and they can be applied otherwise as well. Perfect. Uh, so let us do our final raffle. Uh, if you can see my screen, just let me know. So can you see my screen, Fyodor?
I can see a screen. Yes.
Perfect. So yeah, Concepts in Tamil was our first winner, and we are doing another draw now. This is our final draw to win the book. Amir Sajad
Okay.
on YouTube. Congratulations, Amir. And Amir, if you're still seeing, get in touch with me on LinkedIn. And yeah, I'll be more than happy to get this book for you. As I said earlier, just type my name plus mining publications and search it on LinkedIn, and you'll be easily able to find me. Thank you so much for all of that, Fyodor. Do you want to give out any closing thoughts before we wrap up the session?
Closing thoughts. So a lot of people talking about what skills are still relevant on the market. A lot of people are worrying about software engineering jobs because of AI. And based on my experience, what I would say is that the evergreen set of skills is cloud application development without a doubt, because a lot of people are shipping prototype. Anybody
Mm,
can use AI, build some kind of a prototype, but not that many people know how to apply proper engineering principles and productionize those prototypes.
yeah,
And those principles, like reliability engineering and other related things, is what cloud application is all about.
amazing. Thanks a lot for that, Fyodor. And that's it for today. Follow Fyodor on LinkedIn, follow me on LinkedIn. And I've got quite a few interesting sessions coming up next week and the week after. So hopefully I'll see all of you for that. Uh, Thank you once again and see you next week.
Thank you. Good to see you all here.